In this video, I'm going to show you how to use elimination to solve a system of linear equations with fractional coefficients. Here we've just got a single fractional coefficient, this 1/5 on the x. But if we carry this through elimination, that'll kind of defeat the whole purpose of elimination. The point of elimination is to avoid using any fractions during our computations, but if we carry this 1/5 through, then we'll be using a fraction. So how can we get rid of this 1/5? Well, we can get rid of fractions by multiplying them by things. And in elimination, we're allowed to multiply equations by numbers. So what number can we choose to multiply this equation by that'll cancel out that 1/5? Well, any number that's divisible by 5 will cancel out this 1/5. So let's choose the smallest number that's divisible by 5, just the denominator here, 5. So if we multiply this equation by 5, we get 5 times 1/5 is just 1x, so the fraction is gone, and then we also have to multiply the other terms by 5. So x plus 5y equals 20. Great, no more fraction here. The bottom equation didn't even have a fraction to start with, so we can just keep that the same, times 1 to get 3x minus 10y equals 10. Alright, so now we have all integer coefficients, and this is more familiar territory. We can go ahead and perform elimination as usual. So what can we cancel here? Well, there's an x and a 3x, there's a 5y and a minus 10y. These y's can cancel if we multiply this 5y by 2. If we can get this 5y to 10y, then it'll cancel with this minus 10y. So let's multiply this equation by 2 on top, so you get 2x plus 10y equals 40, and the bottom equation will keep the same, times 1, so 3x minus 10y equals 10, and now we can add the equations because this 10y will cancel with that minus 10y. So let's go ahead and add this 10 and minus 10 cancels, and we just get 2x plus 3x, 5x equals 40 plus 10, 50. Now, to solve for x, we can just divide by 5. So x equals 50 divided by 5, which is just 10. And now we're almost there. We have x, and we just need to solve for y. So to get y, we can use any of these equations, because x and y, our solution, will satisfy any of these equations. So how about, let's use that one. This one right here looks pretty simple. So plugging in x equals 10 to this equation, we get 10 plus 5y equals 20. So then subtracting 10 from both sides, we get 5y equals 10. And then dividing by 10, or dividing by 5 rather, we get y equals 2. So that's our solution. X is 10, y is 2. Let's do another example. Here's another system of linear equations with fractional coefficients. We've got this 1/3 on the x in the top equation and a 1/2 on the x in the bottom equation. And again, we don't want to carry this 1/3 and this 1/2 through our elimination computations because that would defeat the whole purpose of elimination, which is not to deal with fractions. So we're going to multiply each equation by something to cancel out the fractions. So for the top equation, we need to cancel out the 1/3. So we want to multiply by a number that'll cancel out that 1/3. So any number that's divisible by 3, and the simplest one would just be 3 itself. So let's multiply by 3, and 3 times 1/3 is just 1x, and plus 3y equals 3. Okay, now in the bottom equation, we have a 1/2. So we need to multiply by some number that's divisible by 2, the simplest of which is just 2 itself. So we'll multiply by 2, that'll cancel out that 1/2, 2 times a 1/2 is just 1, so we have x plus 4y equals 10. Okay, now we have all integer coefficients, and we're good to perform elimination as usual. So what's the easiest thing to eliminate here? Well, if we turn one of the x's negative, then they'll cancel out. So why don't we turn this bottom x negative. Multiply this bottom equation by -1 and get negative x minus 4y equals -10. And the top equation will keep the same, times 1 to get x plus 3y equals 3. Now we can go ahead and add these equations because the x's will cancel. So x minus x, that just cancels out. And then we've got 3y minus 4y. 3 minus 4 is just -1. So negative y equals 3 minus 10. That's just -7. So multiplying by -1, we get y equals 7. Great, now we've got one of the variables and the rest is pretty straightforward. We just need to substitute y equals 7 into one of these equations to solve for x. So why don't we choose, say, this one again. So substituting y equals 7 into this equation, we get x plus 3 times 7 equals 3. And we'll just go ahead and compute this. So x plus 21 equals 3. And subtract 21 from both sides, we get x equals -18. So our solution then is just x equals -18 and y equals 7. Let's do one last example. For our final example, we have a bit of a trickier system, and the reason the system is trickier is because there's a ton of fractions in it, and a lot of them have different denominators. So how are we going to get our 3/4 and our 3/2 and our 1/3 and our 3/5 and our 9/5? How are we going to get these all to integers? Well, let's just take it one equation at a time. Let's look at our top equation. So if we multiply this equation by anything that's divisible by 2 and divisible by 4, that'll cancel out both of these fractions. So we just need to find the least common multiple of 2 and 4. And that just happens to be 4. 4 divides 4 and 2 divides 4 also. So let's multiply this top equation by 4. And 4 times 3/4, we just have 3x. And then 4 times 3/2, well, that's like 12 over 2, which is just 6. So 3x minus 6y equals 16. Okay, that wasn't too bad. So let's look at our bottom equation, and let's do the same thing. We need to find the least common multiple of 3 and 5, some number that's divisible by both 3 and 5. And the easiest way to get there in this case is probably just to multiply the numbers, get to 15. So multiplying will always work. Sometimes, like here, if you multiply 2 and 4, you get 8, but there's really a simpler one. But if you can't think of any, then you can always just multiply the numbers, and that'll get you there. So let's multiply this equation by 15. And 15 divided by 3 is just 5, so 5x. Then 15 divided by 5 is 3, and 3 times 3 is 9, so minus 9y. Equals 15 times 9/5. So 15 divided by 5 is 3, and then times 9 is 27. All right. So now we have our system has all integer coefficients, and we can solve it as usual. So what's the easiest to eliminate here? Well, how about this 3x and this 5x? If we multiply this top equation multiply that by -5 and multiply the bottom equation by 3, then this will become 15x, and that'll become 15x. That'll become -15x, and this will become positive 15x, and then those will cancel. So let's carry out that multiplication. Top equation times -5, we get -15x, then plus 30y equals -80, and then the bottom we have positive 15x minus 27y equals 27 times 3 is 81. Okay, so now we have our 15x and a -15x, so if we add, those will cancel. And then we have 30y minus 27y. 30 minus 27 is just 3y. And then 81 minus 80, that's just 1. So 3y equals 1, and we can just divide by 3 to get y equals 1/3. Okay, so now it just remains to figure out what x is, and let's go ahead and substitute this y equals 1/3 into one of these equations. How about this one again? This one looks the simplest. So let's do 3x minus 6 times y is 1/3 equals 16. So just computing this, we've got 3x minus 6 divided by 3 is 2. That equals 16. So adding 2 to both sides, we get 3x equals 18. So x equals 18 divided by 3, which is 6. And then there's our solution. X is 6 and y is 1/3. The main takeaway of this whole video is that if you want to use elimination to solve a system of linear equations with fractional coefficients, your first step should be to get rid of the fractions. You need to multiply by some number that's the least common multiple of the denominators of the fractions, and that'll get rid of the fractions for you, and you'll just have an integer system, and you can solve that as usual. In the future, we'll also learn how to deal with decimal coefficients as well.